This video is about identifying the domain and range given a situation, table, or function rule, and determine what an ordered pair means given a function rule or situation and whether the point is realistic. So first we need to talk about what domain and range are. Domain goes with your x values. So the domain is the possible values for the input of your function. It's the possible values that work as your independent variable. So the range we can think of as our y's. The range is the possible outputs of your function. It is the possible values that will work for your dependent variable. So let's look at some situations to determine domain and range. So Matthew and his friends are ordering pizza. Each pizza is $8 and Matthew decides that they should tip the delivery driver $5. Fill in the table to show how much it will cost Matthew and his friends to order pizza. So if they order one pizza, it costs $8 per the one pizza plus the $5 tip that they're going to give the driver, which would get us $13. If he orders two pizzas, 8 times two pizzas plus the $5 tip would get us $21. If he orders three pizzas, that would get us $29. If he gets 10 pizzas because they're really hungry, 8 times 10 plus the $5 tip would be $85. So following the function rule, notice that for number of pizzas we have n and total cost we have c. Our function rule would be c equals, because we're determining the cost, $8 per number of pizzas plus the $5. So in this case, we have two variables. We have pizza, which would be considered our independent variable, and cost which would be considered our dependent variable. So if we go to write a dependency statement, we would say the total cost depends on the number of pizzas. So in this case then, our independent variable is the number of pizzas, and our dependent would be the total cost. So in the domain in this situation, all the numbers of pizzas you can buy, because the number of pizzas is the independent variable. So we need to think about what kind of numbers work for pizza. Well, if I'm going to order pizza, I can only order whole pizzas. So when I call to order a pizza, I would have one pizza, two pizza, three pizzas, four pizzas, all the way up to n number of pizzas. Another way to say this, notice that we're going up by one positive integer each time. So we could say integers greater than or equal to 1, because we can order one pizza or any integer that's greater. And remember, integers only include the counting numbers that are positive. They do not include the fractions for greater than 1. The range in this situation is the different costs that you would get for pizza because it's the dependent variable. So the range in this case, remember, one pizza costs $13, two pizzas was 21. Notice that each time we add a pizza, our cost is going up $8, and we can continue using our function rule to figure out the cost. So 8n plus 5. So now we need to think about the situation of the function rule versus the graph of a function rule. So if I just think about the pizza and tip situation, we said that our domain was the integers greater than or equal to 1, and our range was 13, 21, 29, any number that followed the pattern 8n plus 5. If we use the function rule, we're just graphing a line. So when we're graphing a line, we can use anything for x's. We can use negatives, we can use decimals, we can use fractions. So our domain would change if it was just a function rule to be all real numbers, because that includes negatives, positives, integers, zero, whole numbers. Everything's included with all real numbers. In the range, depending on what number we put in the x, if we can put anything in for the x, sooner or later we're going to get any type of number out, so our range would also be all real numbers. That's what helps make a continuous line, is that all real numbers is the domain and range. So in conclusion, the domain and range of a function rule and the problem situation are very different. The domain of a function rule include negatives and fractions, which are not included in our problem situation. So let's look at another example. So Dustin decides to paint all the faces he can see in a tower. He fills in the table below. So we have the number of stories representing each block on top and the number of faces painted. Now we're only painting the faces that we can see on the tower. So in the first block, when I look at this block, I can see 1 if I turn the block, 2, 3, and 4 if I turn the block around, plus the top, which gets us 5 painted faces. I don't worry about the bottom because that's the one it's resting on and I can't see something that it's resting on. If I have 2 stories of blocks, I have 1, 2, 3, 4, 5, 6, 7, 8, and the top, which is 9. If I have 3 stories, I have 1, 2, and if I rotate 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, and our top, which is 13. Because we can always see 4 sides of the block plus that very top part, which is 13. So notice that each time our number of faces painted is going up by 4. So write a dependency statement. So in this case, we would have the number of faces painted depends on the number of stories. So in this case, our independent variable then is the number of stories, and our dependent is the number of faces painted. So Dustin determines that the function rule that models this situation is P equals 4s plus 1. Use the function rule to answer the following questions. So what does the point 521 mean in the context? Well, remember that this is our x and our y, or based on the letters, this is our input s and our output p. So if we look at the point, the first number is going to represent the independent variable, which was number of stories, and the second number is going to represent the dependent for number of faces painted. So this means if there are 5 stories, then 21 faces are painted. Now we need to know, is this point realistic in the context of the situation? So to know if it's realistic, we have to think about 2 things. 1, does the number make sense as an input? And then 2, is the output the number that works for the solution? So in this case, does 5 work as an input? Yes, we can have 5 stories. Does it work as an output? So when I put this into the equation, 4 times 5 plus 1, I get 21, which is what the output was. So is this a realistic point? Yes, because it's a solution to the function rule. C, what does the point 3.2, 13.8 mean in the context? So this means if there are 3.2 stories, then there are 13.8 faces painted. Now, in this point, is this realistic? No, because we can't have a partial story. We're using blocks that he's building with. So is this a realistic point? No, because you can't have a partial story. And the reason that would be a partial story is because of that point 2. So what does the point 1050 mean in the context of the situation? So in the context of the situation, it means if there are 10 stories, then there are 50 painted faces. So is this point realistic? Well, we can have 10 stories, so that part's realistic. Now we need to make sure it works in our equations. Remember our equation was 4 times the number of stories plus 1, which is 41, not 50. So this point is also not realistic. So we would say no because it is not a solution to the function. So what is the domain of the situation? Think about what numbers make sense for our stories. So for our stories, we started with one story and then we kept increasing one at a time all the way to n. So another way to say that then is integers that are greater than or equal to 1. The range, so what numbers came out? Well, remember if we painted one face, we had 9, then we had 13, or we had 5, and then we had 9, and then we had 13. And we kept going using our rule 4s plus 1, or 4n plus 1. How would the domain and range look different if it was a function rule? So if it was just the equation y equals 4x plus 1, then the domain and range would be all real numbers. So let's look at another example. During the winter, more crazy storms hit Gurnee. The first snowstorm left 3 inches of snow. Another snowstorm rolled in and is snowing, and snow is coming down at 2 inches per hour. Find the number of the amount of snow after each passing hour. So we are looking at S for the snow inches and H for the hours. So our snow total is equal to, we have 3 inches on the ground already, plus we're getting 2 more inches per hour. So use the function rule to fill in the table. So if we have 0 hours of snow before the next snowstorm starts, we already have 3 inches of snow. After 1 hour, we would have 3 plus 2 times 1, which would be 5 inches. After 2 hours, we'd have 3 plus 2 times 2, which would be 7 inches. And after 3 hours, we'd have 2 times 3, which is 9 inches. So we're going to plot that on our graph. So for 0 hours, we have 3 inches. At 1 hour, we have 5. At 2 hours, we have 7. And at 3 hours, we have 9. Now, in this case, when I'm graphing this, I'm going to connect my line because hours are continuous. And think about snow falling. It just doesn't magically show up with a new inch every time. The snow keeps accumulating until we get to our inches. So on the graph, what would the point 3, 10 mean? Well, remember that 3 is our input and 10 is the output. So it would mean after 3.5 hours, there is 10 inches of snow. So is this point realistic? Well, we can have 3.5 hours, so that makes sense. So we need to test our points. Remember our equation is 3 plus 2 times the number of hours, which in this case would get us 10. So is it a realistic point? Yes, it is a solution to the function rule. So this time, it's okay to have decimals because decimals work based on what our input is of hours. So on the graph, what does 2.7, 10.4 mean? This means after 2.7 hours, there is 10.4 inches of snow. Is this realistic? Well, we can have 2.7 hours, so that's okay. 3 plus 2 times 2.7. This is where we run into an issue because when I put that into my function rule and multiply it out and simplify, I only get 8.4, which means my output wasn't the correct number. So, is this realistic? No, because it is not a function, it is not a solution to the function rule. Which variable represents the domain? So remember, the domain is the input. So our hours represents the domain. What's the domain? Well, the domain, we can use all positive numbers, fractions, decimals. So this is going to be all real numbers greater than or equal to 0. Because when we first start counting the snow, that's a 0-hour time. What interval or what variable represents the range? This would be our snow inches. And what is the range? So remember, for the range, we're starting at 3 and we're going up. Now, if we go back and look at this, 8.4 is not a whole number. It's not following the pattern because we are continuous with our time. And since we are continuous with our domain of using all real numbers, our range is the same thing. All real numbers greater than or equal to the number we start at, which in this case was 3, because there's already 3 inches of snow on the ground.